Hey, Swati here. Welcome back to Python, Zero to Expert. This one's a big, important module. We'll bundle data and behavior into objects, and then go further. How one class builds on another, and how Python handles interfaces. By the end, object-oriented Python won't feel like a mystery. Module 7. A class bundles data together with the actions on that data. But the real power shows up when classes build on each other, and when very different objects can be used in exactly the same way. Let's build up to that one step at a time. 4 steps today. You'll write a class and create objects from it. You'll cut boilerplate with a data class. You'll have one class inherit from another and change its behavior. And you'll see how Python does interfaces without any special keyword. Start with a class, a blueprint for a dog. Dunder init runs the moment you create one, and it stores the name onto the object. Every method takes self first, and self is just this particular dog. So self.name is this dog's name.
One for me, Ryan. Self really isn't magic. It's just the object itself handed into the method. Hold on to that and classes click.
Now use it. You call the class like a function to make an object. A dog named Rex. Then reach in with a dot. d.name gives you Rex. And d.speak runs the method. And notice you never passed self. Python hands the object in for you automatically. That's why methods list self, but you never type it at the call. If a class is mostly data, writing that initializer by hand gets old fast. So one import, and the data class decorator writes the initializer, a readable printout, and equality checks for you. You just list the fields. And before you ask, a data class is still a normal class. Add any method you like, here a distance, and call it normally. 0.34.distance gives 5. Now, the real power, inheritance. A dog is an animal, so we write class dog, and in brackets animal. Dog automatically gets everything animal has, including that init. So, it already knows about name. Then, dog overrides speak with its own version. And see super.speak? That calls the parent's version first. So, you build on it instead of throwing it away. Write shared code once in the base, and specialize in the children. Here's where objects get powerful. Define a cat too, also an animal. Now, this announce function calls .speak on whatever you hand it. It never checks the type. A dog, a cat. As long as it has a speak method, it just works. Python calls this duck typing. If it walks like a duck and quacks like a duck, treat it like a duck. One function, many types. Python has no implements keyword, but when you want that contract written down, you use a protocol. You list the methods you expect. Here, speak. Now, any class that has a speak method counts as a speaker, with no inheritance at all. Your type checker quietly checks it for you. That's Python's version of an interface. Structural and optional.
And if you want to force it, from ABC import ABC, an abstract-based class makes subclasses implement the method, or Python refuses to build them. Protocol is the gentle contract. ABC is the strict one.
Sarah here, and watch it all come together. Shape protocol says, whatever you are, you can give me an area. A circle is a data class, just a radius, with an area method. And that last line adds up the area of every shape in a list, without caring what they are. A data class, a protocol, a method, duck typing, and a comprehension. The whole module, in a handful of lines of real code. And that's object-oriented Python, end to end. You can write a class and use it, cut boilerplate with a data class, inherit and override, and do interfaces the Python way with duck typing and protocols. Rule of thumb: a class when data and behavior belong together. Inheritance for a real is a relationship, and a protocol when you just need a shared shape. Next time, modules and imports. I'm Swathi. This is Codecraft. See you there.